Hello my friends. Now today I am going to discuss some fundamental signal plots which must be used in the signal system analysis topic. Okay. Now let us discuss some fundamental plots. Now suppose the signal xt is equal to 1. Actually here I am covering the continuous time signals. Try to understand what type of signals I am covering now. Continuous time signals. So now xt is equal to 1. How to sketch it? It is very simple. So now this is your time axis suppose. Now 1 means what? Here nothing is mentioned. No constraint is mentioned for t. If nothing is mentioned for t, that means you have to consider for all t. The plot is for entire time axis. Understood? For all t, that means it is given that xt is equal to 1 for all t. For all time, xt value is equal to 1. So that means how to sketch? See here, this is 1. Now this is your xt. xt is equal to 1 for all t. This time 1, this time 1, this time 1, this time 1, this time 1. For every time it is 1, means constant. Okay. So if there is no constraint for t, that means you have to imagine the plot must be for all t. That means for all t, this value is 1. Now suppose I am considering xt is equal to 2. Then how to sketch it? This is your time axis. Now this is your 2. Okay. Now this is your 2. So now this time 2, this time 2, this time 2. Every time the value is 2. This is xt is equal to 2. That means here xt is equal to 2. Nothing is mentioned for t. That means you have to sketch for all time. It means that for all time the value is 2. It means that for all time the value is 2. Okay. So xt is equal to 1, xt is equal to 2. Similarly, xt in general you can say xt is equal to a. A is any constant. xt is equal to a. That means here nothing is mentioned, means for all t it is defined as a. This is a for all t, xt. That means here this time a, 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 this time a. For all t it is a. Understood? Okay. Next see, next plot. Suppose actually here it is given xt is equal to t. Here nothing is mentioned. That means for all t you have to plot actually t. Here y is equal to mx. You have to plot the equation of a straight line which is for minus infinity time to plus infinity time. That is for entire time you have to sketch y is equal to mx. So that means see, this is time axis. Slope is 1, positive slope, means rising. C, mx plus c, c is equal to 0. Here nothing is mentioned for c, c is equal to 0, y is equal to mx. That means this is the plot. This is the plot. It passes through origin and it is the straight line which is from minus infinity to plus infinity. For entire time axis, this is actually the plot. Try to understand. xt is equal to t, the plot is this. Okay. Now similarly, suppose another signal is given xt is equal to t square by 2. That means see, it is a parabolic signal, but for all t. Here nothing is mentioned. Nothing is mentioned for t. There is no constant for t. That means you have to sketch for all t. So it is parabolic for all time. That means this is the sketch. That means you have to consider the negative axis also, negative time axis also for all time. Mathematically, you have to consider for entire time axis. There is no meaning of for negative time. But mathematically you are considering. For sketch you have to consider for all t, this will be the sketch. Try to understand. This is your xt. This is 0. Okay. This is your t square by 2. T square by 2 means both sides you have to sketch because you have to sketch for all t. Okay. Now, suppose another sketch, another signal is given. Next, suppose actually xt, it is given. Suppose the signal you can consider this is your ut. Now here nothing is given for t, no constant for t, but ut already known to you is a defined signal. It is a defined signal. That means here within it, in the definition itself, there is a constant for t. There is a constant for t in the definition of ut. So therefore, you have to consider this plot in this manner. Because you know itself what is ut. This is the definition of ut. This is the plot for ut. So therefore, xt is equal to ut will give you this plot. Here actually there is a constant for t. T less than 0 value 0. T greater than 0 value is 1. And t is equal to 0 value is half. Half means you have to take average value. I have discussed. Final plus initial by 2. That is 1 by 2. At 0 it is not defined. At 0. So therefore you have to take average value. Understood? So xt is equal to ut will give this plot. Now suppose xt is equal to del t. You know del t? This is your time axis. Del t means actually within it, in the definition of del t, there is the constant for t. That means for t is equal to 0, its value is infinite. For t is not equal to 0, the value is 0. And area under this function is equal to 1. So therefore, accordingly, you have to sketch. This is the notation which is, this is a graphical symbol which is used for the impulse signal del t. Okay? So this is the sketch for del t, which is known as delta function or impulse function. Direct delta भी इसको बोला जाता है. समझ में आ रहा है? Good. Now, suppose you are having xt is equal to rt. So nothing is mentioned for t, but within the definition of rt, already the restriction for t is given. Okay? So that means t का range given है. कौन सा range पे क्या होगा? It is given. So that means this is your time axis. Now this is your rt. Slope is 1. Slope equal to 1. Okay? So this is the signal which is your ramp function rt. Okay? When this notation is given, it is ramp function rt. xt is equal to rt. Okay? Now next see, suppose xt is equal to parabolic pt. You know pt? pt is equal to what? pt is equal to t square by 2. But when this is t greater than or equal to 0 and it is equal to 0, t less than 0. That means within the definition of pt, already t range is mentioned. In what range? Which equation? That is mentioned. So therefore, what you have to do, this is your time axis. Now pt you can plot in this manner. This is t square by 2. Not for the entire time. You should not plot this in this side. You have to plot only this side. Only in this side. Why? Because in the definition of pt, this time range is given. This range, this equation. This range, this equation. So therefore, xt is equal to pt is nothing but a t square by 2. You have to sketch actually in this manner, in one side. Okay? So now suppose I am having another signal which is a xt is equal to mod t. Try to understand. Here a mod t. In the definition of a mod t, already t range is given. In what range of t, what value you have to sketch, what equation you have to sketch, that is already within the definition of a mod t. So you know mod t is equal to t for t greater than 0. It is equal to minus t for t less than 0. That means t greater than 0, this plot. T less than 0, this plot. This plot means what? Mx. This plot means what? Mx. Here m is 1, here m is minus 1. And in this equation, c is 0, mx plus c, here mx plus c, here c value 0, here c value 0. Then what you have to sketch? This is your time axis. Now t greater than 0, t greater than 0, y is equal to mx. Actually this is xt, xt means mod t, y is equal to mx. So that means straight line passing through origin, slope 1. This is slope is 1. Now here xt is equal to minus t, t less than 0, t less than 0 this side, xt is equal to what? Minus t, mx, slope is negative, minus 1 and passing through origin because c is 0, mx plus c, c is 0. That means this is the straight line. Here also slope is minus 1. So this will be the plot, this will be the plot for xt is equal to mod. Okay? Now again see, suppose the signal is xt is equal to e to the power minus t. Now nothing is mentioned for t. That means you have to sketch for entire time axis t, for entire t. Here you have to sketch for the entire time. That means this is an exponential decay function. You have to sketch for the entire time. And at t is equal to 0, e to the 0 is 1. T is equal to 0, value is 1. This is exponential decay function. So this is your xt. Xt is equal to e to the minus t. This type of plot you find. Now let us discuss another signal. Xt is equal to e to the power t. Xt is equal to e to the power t. Here t range is not given. That means you have to sketch for the entire time axis. So this is your time axis. This is exponential rising. This is an exponential rising function xt. So now this is rising. Negative time, positive time, both you have to plot. So now 0 value is what? 1. T is equal to 0 value is 1. E to the 0 is 1. The value is 1. This is exponential rising function. Okay. So next, suppose xt is equal to, try to understand, suppose I am having xt is equal to e to the power minus mod t. So here mod dimension means in what range, what equation that is given. Because the mod t definition, in what range what, that is given. So therefore, if you put the definition of mod t here, then we will find e to the power minus t. Mod t is equal to t for t greater than 0. Now is equal to e to the power t. Mod t is equal to minus t. The minus minus plus e to the power t for t less than 0. Mod t is equal to minus t for t less than 0. Now if you put minus t, minus minus plus e to the power t for t less than 0. So now if you sketch, what type of sketch you will find? See here, this is the time axis. Now t greater than 0, e to the minus t means t greater than 0, e to the minus t means this. Value is 1. Actually you can put greater than equal, there is no problem, because at 0 both having value 1. Now t less than 0, value is e to the t, that means rising. But 0, if you put t is equal to 0, value is 1, e to the 0 is 1. Okay, so this is the sketch of e to the power, this is xt which is equal to e to the minus mod t. Okay, so now let us sketch another signal which you have already acquainted. Now signum function SGNT, signum t. So how to sketch this signum t? So you know this signum t, that means suppose xt is equal to signum t. Within the definition of signum t, you know the range of t. In what range, what equation? That you know within the definition of signum t. So therefore, the signum t plot you know, so accordingly you just sketch. This is actually 1, this is minus 1. This is signum t. This function, this sketch is for signum t. Okay. Next let us see, because these things are already I have discussed in my previous videos. You just see my previous videos. Entire discussion of this signum t you will get. Okay. So next is xt is equal to, see, xt is equal to sampling t. You know sampling t? Already I have covered sampling t. Just I am showing the plot very quickly. So sampling t, I have told here the value is 1 and this is gradually decaying. Here the value is 1 and this is gradually decaying. But remember, here this value is pi, this value is 2 pi, this value is minus pi, this value is minus 2 pi. And remember, this width is pi, this width is pi, but this width is 2 pi. So therefore this is known as major lobe. Major lobe of what? Major lobe of the sampling function. And here the amplitude value gradually decreasing. Here whatever the amplitude, here the amplitude is less. Here whatever the amplitude is less. So this is nothing but known as sampling t. Now let us let us plot another signal which is the sync t. So that means you just mark xt is equal to sync t. So how to sketch it? This is your time axis. Now sampling t, sync t, same. So that means both plot you can say in this manner. 0 value is 1. Now here this value is not pi, this is 1. This value is 2. This value is minus 1. This value is minus 2. That means here the range is 1. Here the gap is 1. Here the gap is 1. But here the gap is 2. Minus 1 to 1. The gap is 2. That means this is nothing but known as major lobe. Major lobe. This is the major lobe. Major lobe. Okay. So this is nothing but known as a sync t. See, these plots are having frequent application in the future signal system discussions. So therefore, you have to remember the plots. Actually, no need to remember. After discussing many times, automatically the plots will be in your brain. Okay. Now see, suppose xt is equal to a rect t by tau. This is rectangular pulse. How to sketch? This is your time axis. Now this will be the plot. Here tau is nothing but the total width of the pulse. That means minus tau by 2 to tau by 2. And it is same spread around this axis. That means it is even signal, that I will discuss later. What is the concept of even signal? I will discuss later. Now this is minus tau by 2 to tau by 2. This range is tau. And here what is the height? Height is a. What is mentioned here? This is actually height. This is known as rectangular pulse. This is known as rectangular pulse. This is your xt is equal to a rect t by tau. Now, suppose I am having another signal xt is equal to a triangular t by tau. Now mark, in xt is equal to a rectangular t by tau, this tau is the total width, but this tau is the one side width, not the total width. That means here this is time axis and here this is the pulse, triangular pulse. This is tau, this is minus tau. Now total width is 2 tau. Though tau is mentioned here, this is one side width. One side width is tau. Now here A. Remember, this is the difference between this notation and this notation. Very important. This is triangular pulse. This is your triangular pulse. Okay. So similarly, you can sketch a sinusoidal signal. You know, xt is equal to sine omega t. A sine omega t. Omega is the frequency, you can say. Now, what is the plot? This is very simple. This is very simple. That means the amplitude is A, sine signal starts from origin, this side, and also you have to consider this side, because nothing is mentioned means you have to sketch for the entire time axis. Nothing is mentioned means you have to sketch for the entire time axis. But in case of rectangular pulse, in case of triangular pulse, so there is the restriction in t. That means for a what range of t, you have to sketch this, and for other range of t, that value is 0. Values are 0. Understood? Here actually xt is equal to a sin omega t. That means you just mark this amplitude is a. This is amplitude is a. This point is, this value is a. This value is minus. Okay. Similarly, you can sketch xt is equal to a cos omega t. Try to understand what will be the sketch. Xt is equal to a cos omega t. That means this is your time axis. Here your signal xt. A is amplitude. Now at 0, cos signal having value a. Cos 0 is equal to 1. A into 1. That is A. That means it will start from A. You have to sketch in this manner. Both sides you have to sketch. So this amplitude is A. This is your minus, you can see. So this is your cosine signal plot. Understood? So that means many signal I have plotted. These are just the fundamental signals. These signals you must know. These are the minimum signals you must know, and it's a plot you must understand and remember also for the future application of signal system topic. That means what I have covered in the sketch, I have covered xt is equal to 1, xt is equal to 2, or xt is equal to a. Then I have covered xt is equal to t. Then xt is equal to t square by 2. Then xt is equal to c. I have covered already mod t. Understood? Then xt is equal to ut. Then xt is equal to rt. Then xt is equal to parabolic function pt. Then xt is equal to impulse, also I have covered del t. Try to understand. I have covered all these plots, and also I have sketched in this class. Okay. Now xt is equal to a rect t by tau. I have sketched. Xt is equal to a triangular t by tau. Xt is equal to signum t. Xt is equal to sampling t. This sketch also I have mentioned, or I have already made. Xt is equal to sig t. Okay. Xt is equal to sin omega t, or a sin omega t, whatever is just mark. Xt is equal to a cos omega t. So these plots, these are the just basic plots. These basic plots you must have to remember. Okay. In my next video, I will discuss either operation on signals, or that means operation on time, operation on amplitude, etc., etc. Or I may cover different classification of signals, NR signal, power signal, etc., etc. So I will discuss and I will think what I have to cover in my next video. Okay. Thank you.